I just started this without making any plan of what I was going to say. And I know what you're thinking. You're thinking, Maggie, do you ever plan what you're going to say? And I assure you, I do. I have main points that I want to hit. I didn't plan that out. So here we go, winging it. Day 5 question mark or whatever we are on of this derivative exploration. All right, so today I backed up because yesterday's thing, what did I do yesterday? Differentiability. That got me lost. So I was like, let's back up and redo things. And I watched a bunch of Khan Academy videos, and now I feel like my epiphany was not very deep or smart because Sal Khan has gone through so many different videos and ways of explaining that, like the whole secant to tangent line thing that I was so proud of understanding. And now I'm like, yes, that is what it is. So much so that he went over it many times. So part of me is like, that was a dumb epiphany to have, but is it really a dumb epiphany if it's true learning? And I guess that answer is no, it's not. He also, all right, I wanted to show this. I'm gonna screen share with you guys real quick. Screen share. Here we go. All right. So are we checking this out right here? We've got this whole situation going on. So Sal started out over here being like, all right, we're going to do x squared. And what is it at 3? And then works this whole thing out. But like even here, I was going, well, it's 6. Because as previously stated many times, the derivative of x squared is 2x. So he did all of this work and then it took many minutes. It is an 8.5 minute video. So I wanted to validate myself real quick again about when I first learned all of this and was so pissed to do all of that work by hand only to find out the power rule later. And then I also did some example problems finally where I was doing things well. The thing that I messed up was derivatives of natural log, where I was dealing with E, kind of messed those up a couple times. But other than those, I did very well on them. But for those, instead of doing the long form way of figuring out the derivative, I just did power rule for all of those problems, which, you know, that's okay because even though using the power rule is using kind of instrumental learning, I actually do have instrumental understanding. I actually do have relational understanding now that I didn't have before. And you don't have to use the long equation to understand what is going on with the long equation and why it works. So part of me felt guilty, like I was cheating maybe. But I'm not, right? Because even though using the power rule, which I know is not going through the whole process and understanding how to do the whole process, I feel like I understand what is going on in the whole process now in a way that I didn't previously. And I can use the easier way for solving problems. So that was a big success today, was solving problems on the Khan Academy website and understanding, like, getting those correct. I did a thing that my students do. Why is it when I'm teaching, I see these things, and when I'm being a student, I don't? One of the problems was, I think, x squared plus 3, something like that. And I even said to myself, make sure that you use the plus 3 when you solve that equation, because the derivative is the same, it's still 2x, but when you are finding the tangent line to the equation, you have to use the point that's actually on the parabola. And even though I reminded myself that I needed to do that, I still did it wrong. So, I was acting like a student in that moment. Oh, and other ridiculous thing, I couldn't figure out how to do that at first. So I made fun of that in a previous video, being like, is calculus, algebra 1, this is just algebra 1, and it said find the equation of the tangent line at this point. And when I had to do all of the parts, when I had to figure out the point, figure out the derivative, and do it all, and then find the line, I was like, I don't know how to do this. This is crazy. I don't like the word crazy. This is bonkers. This is unreasonable. Oh, Maggie, you sweet summer child. So that was I felt embarrassed for myself, and I could have just not told you about that. I could have just had that to myself and not told you that I went through that whole thing, but that is part of the adventure of learning all of this. So I still have a goal of getting back to the area problem and looking at that more. I do know that we are talking about a summation situation there, blah, 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 blah. There's a lot going on. But I clearly needed to do more work here before I can move on to that next thing. But we are getting closer to understanding what's going on. And I don't know if I explained this in the beginning, but like my whole point in this exploration is that I really feel like I had a cliff drop off on my mathematical content knowledge, that like I do tutor algebra 1 geometry and algebra 2 so often that I'm super used to that curriculum, and that I sometimes do tutor pre-calculus and IB math studies, but usually the students who make it into those higher level math courses are doing fairly well on their own and only come to see me once in a while as needed. So I kind of have this math drop off point as the limit approaches calculus. As we approach calculus, Maggie's knowledge approaches the limit of 0. So I wanted to fix that. I wanted to make that different and better, and not be a drop off. I wanted this to continue to be an area of knowledge and growth. So here we are on this journey, and I don't know if we're gonna finish it on time. Lots of studying, lots of learning. So thank you. You rock. If you've watched this, it means you're amazing.